All right, and welcome everyone to Smart Contracts Explained. My name is Pavel. I'll be your host for today. This workshop is for people who have heard of Ethereum and people who are interested in how Ethereum smart contracts work. If you also have development experience, this would be very helpful. But again, this is tailored to people who might not have that experience as well. My name is Pavel. I'm a software engineer. I authored blockchain development videos and tutorials. I also created and led the CryptoChicks Hatchery blockchain program, which helps educate entrepreneurs looking to start a decentralized business. I also enjoy teaching blockchain development topics worldwide. Oh, and that's my headshot. I'll be going over what a smart contract is, the uses of a smart contract, the difference between a call and a send transaction, as well as the difference between an externally owned account and a contract account. And I also will go over why we should not store a large amount of data on the blockchain. So today we'll be going over the three main topics: the architecture, the smart contract, as well as a bit of the coding aspect. And hopefully these three perspectives will give you a whole idea of what a smart contract is and what it can do for you. So why are smart contracts important? Well, smart contracts eliminate the need to trust. Essentially, it's an if statement, if then. I will X if Y. Some examples of this: I will give you the deed if you buy at the listed price. I will notarize this document if you provide the info. I will record your vote if you validate your identity. I will give you the winnings if the Toronto Raptors win. And in that case, that actually happened. Nick Szabo is the original creator of the idea of smart contracts, and he mentioned that a smart contract is a set of promises specified in digital form, including protocols within which the parties perform on these promises. In more, in simple terms, he also mentioned within the same paper, is that a canonical real-life example, which we might consider to be a primitive ancestor of smart contracts, is the humble vending machine. So what is a vending machine? Well, we have Alice to the right and a Super Cola machine on the left. Now, Alice has $1. Alice goes and selects the Super Cola, or in this case, Crab Cola. She takes out her $1 and telekinetically inserts it into the Super Cola machine. Out comes some Crab Cola, which she, again, telekinetically grabs and thoroughly enjoys. So what is a vending machine? Well, first, Alice selects an item. Second, Alice puts money into the machine. And third, the Crab Cola is dispensed. Let's talk about a vending machine contract. We want to be able to see all the drink tokens available. We want to send a transaction to the smart contract and receive back a Crab Cola token. Taking a look on the right, we are an Ethereum address. We currently have 1 Ether. To interact with the contract, we want to first send a contract call. We get the menu from the contract, and out comes the menu, which is Crab Cola, Crab Classic, and Crab Max. I mean, there's probably more menu items, but that's all I can think of. Now that we know the menu, now that we know which tokens are involved, we want to send a transaction and buy one of the tokens. So in this case, we send half an Ether, and we also pay a transaction fee. So in this case, we pay the base fee of 21,000 gas plus a number of processing gas fee of 19,000, which in total is 40,000 gas. We multiply it by the amount of GUE per unit of gas, and we get 0.004 ETH. Now we subtract that amount from the current amount of ETH that we have, and we are left with 0.4696 Ether. Then we receive our Crab Cola token once the transaction is posted and processed and accepted. And now we have our Crab Cola token. Perfect. Sending a transaction to a contract costs gas in order to send the initial transaction plus every operation involved. Notice that it also costed additional gas in order to process. It costed 21,000 gas as a base transaction and 19,000 gas for additional interaction with the contract. So 40,000 gas total. It goes from an external account to a node to the Ethereum blockchain network. And processing is done by all of the nodes in the network. So every single node has to agree that this transaction went through. And every single node has to run this transaction. This is called, processing is done in this case inside of the Ethereum network. And this also changes the state every single time. Even if you don't change, even if you send Ether to yourself, it still adds a transaction, adds a block to the blockchain. And finally, it returns the transaction hash, which in this case is the receipt, which then you can use as a reference in order to see your transaction and its status.